I am P130939 and this is P130528. We are going to explore how an out-of-classroom environment can develop a child's scientific and innovation skills.
Learning can occur in many contexts, not just in the classroom. For instance, Johnston and Ahmed Williams, 2009, believe that outdoor environments can be used to explore all aspects of the national curriculum. Outdoor learning provides teachers with the chance to expand on their teaching and bring their lessons alive, encouraging children to question the teacher as well as being experimental, with the teacher being a facilitator, keeping them on track but giving them the opportunity to explore what they want. Weisberg 1986 strengthens the idea of outdoor learning as it takes down the rules that are acting as barriers, preventing children from the freedom that allows flexible thinking.
This can be strengthened by Piaget's constructivist views on education, where he has been cited in Gray and McLean 2012 describing a child as a lone scientist, creating their own sense of the world, which he goes on further to say how a child can think about the world before they can express their thoughts through language. Children are seen to be scientifically creative before they can read, write or use language, according to Driver 1985.
Another constructivist in Gray and McLean 2012 is that of Vygotsky, who believes that language is a strong, powerful tool within a child's interactions, allowing them to question the world around them. This can be seen as a developmental stage within a child's lifelong learning, which outdoor learning can advance on, as it is seen to develop a child's inquiry and experimental reflection of their surroundings.
Outdoor learning for children within the early years provides the children with a stimulating source of fascination. There is no limit to the skills and experiences children gain from outdoor learning, which provides all children with different curiosities, allowing peer collaboration and stronger learning environments. WAG 2008 strengthened the idea of curiosities by stating the promoting of creativity within education helps to stimulate a child's curiosity, imagination and exploration, which can aid their confidence and self-esteem. Studies such as the benefits of outdoor learning prepared by the School Travel Forum and Michael Grove shows that outdoor learning has shown to improve personal and emotional well-being, improve connection with their natural environment, their community and their society and also themselves. The study also showed the improved enthusiasm and confidence in learning.
Within the Creative Development Framework document by WAG 2008, it goes on to state that a child's curiosity and disposition to learn is ought to be enthused and inspired through everyday experiences both indoors and out. Creative learning promotes a wide range of skills such as experimentation, speculation, risk-taking, as well as having the ability to develop links and connections. Creative learning is seen under 4 characteristics. The first being relevance, which means learning is operating within a broad range of accepted social values, whilst being attuned to pupils' identities and societies and cultures. The second characteristic is control of learning process, where the student becomes self-motivated. Ownership of knowledge is the third characteristic, where the student becomes to learn for themselves. The fourth and final characteristic, innovation, is where something new is created, a new skill is mastered, and a new understanding is realised.
Innovation allows the child to develop a greater understanding. It builds upon the child's previous knowledge and observations, as it allows a varied array of new knowledge that is acquired, internalised and processed through the person. This can be seen as learning. Learning is learning how. It includes failure, practice, and thinking of different strategies, different skills, and different ways of doing things. Children need to think about what they are trying to do and how and why they are doing it.
These skills can be linked with Olorenshaws and Ritchie's 1997 cycle of scientific inquiry, who believe that scientific inquiry occurs in everyday life through 5 stages. The first stage is that of orientation, the main idea that springs into a child's mind, producing a question. This then leads on to prediction, allowing the person to explore their question, gaining further questions of exploration. Thirdly, we have preparation, which identifies an option of answering the question through planning. There is then the investigation, where the person will carry out the task, and finally the evaluation process, which allows us to discuss and analyse what has happened.
There are also many transferable skills that are gained whilst creative learning and development occurs. Transferable skills entitle the child to use these learnt skills in other subjects across the curriculum and also socially. For instance, we have cognitive skills, which is one of the skills identified by the national curriculum. It gives children the ability to try out new ideas and become more able to take risks as their confidence grows. Technical skills that helps children manipulate resources and ideas to anticipate demands and consequences to sustain engagement. This is a huge confidence booster in relation to language skills and in order to manipulate a sentence. It encourages the child to problem solve in experimentation, which outdoor and scientific learning promote. Technical skills are nurtured through hands-on experiences promoted by outdoor learning, as well as the ability to gain patience and determination.
On the other hand, social skills are just as important, as they provide participative engagements in order to encourage the use of using each other as a form of resource. Working alongside each other promotes leadership skills in order to get the task complete. Learning from others can also help and lead to the child's existing knowledge and radical self-development. Within this, a child can develop a feeling of self-worth and a boost of self-esteem, providing them with the ability to explore risks and ideas with the willingness to speak up about their prior knowledge. Overall, creative and innovation skills enhance and implies the whole of the learner, in which it develops a learner's understanding of the curriculum, pedagogy and social learning to engage within learning.
Not only is outdoor learning out in the playground, it occurs anywhere outside of the classroom, such as zoos, farms, country parks, museums and places like Techniquest and Plantasia.
These are all very hands-on trips, allowing students to be involved, such as feeding animals and learning about the day-to-day needs of their environments, promoting a knowledge of geography, not only scientific. Therefore, it is very cross-curricular. They also offer curriculum-based presentations and talks for classes based upon their term topic chosen by their teacher. Majority offer detailed information about their learning environment on their websites in a child-friendly way, allowing enthusiastic pupils to develop the knowledge gained on the trip back at school or at home.
There are also forest schools and beach schools, which all promote scientific and creative learning in a range of areas, allowing children to explore, engage and be enthusiastic in what they are learning at the current time. Sometimes places like these are trips for children, therefore they do not realise they are learning. However, they continually ask questions about the current surroundings, building upon current knowledge. This video shows the thinking, questioning and doing of the scientific cycle and how children learn through questioning and having hands-on experience.
The children's video was taken indoors but shows and promotes the questioning that can be transferred by children and adults to engage with the skills an outdoor learning environment can provide.
What's in the sky? What's in the sky? What beeps at me up there so high? Who tells me it's a brand new day, so I can play and have fun? Oh yes, I know that is the sun. What's in the sky? What's in the sky? What thunders up there so high? What pours down to the city? What's grey when it's raining loud? Oh yes, I know that is a cloud. What's in the sky? What's in the sky? What are those colours passing by? There are seven bending like a bow, beautiful standing in one row. Oh yes, I know that is a rainbow. What's in the
Who do we
sky?
have
What's in
here?
the sky?
Hello, Genius Giraffe. And what have you been up to this week?
What's up so bright and sharp? What keeps up there so far? Oh yes, I know that is a star.
And this colourful
What's in the sky? What's in the sky? That white pole
Good
shining
question,
up
Genius
high.
Giraffe. Do any of you know what this colourful shape was in the sky that Genius Giraffe is describing to us? That's right, a rainbow. Does anyone know what the weather must do in order for us to see a rainbow?
What's in the
That's
sky?
right,
What's in the sky?
rain. And in order for us to see a rainbow
What's in the
after it has
sky?
rained, we must use one of our 5 senses. Do any of you know which one of our 5 senses we have to use in order to see a rainbow? Do you, Genius Giraffe?
Well, I think it's to do with the eyes. So sight.
That's right, Genius Giraffe. We must use our sense of sight in order to see a rainbow after it has rained. Right then, in order for us to know more about a rainbow, we need to call in one of our neuron scientists, the one with the best sight. Can you help me call her after 3? 1, 2, 3. Professor Membrane. Oh, that's far too quiet. Let's try it again. 1, 2, 3. Professor Membrane.
Oh, hello. For looking and seeing day or night, I will help with your sense of sight. What did you see this time then, Genius Giraffe?
Genius Giraffe has been telling us that he saw a rainbow high up in the sky while he was eating some leaves off a tree.
Oh wow, a rainbow! They are so pretty. A rainbow exists because of light and water, did you know? A bit of science there.
Well, what does a rainbow look like, Professor Membrane?
Wait right there and I'll get one for you.
This is so exciting.
Here's a rainbow.
Wow! Look at all those colours in the rainbow. How does it have so many colours, Professor Membrane?
Well, when the sun shines down on the earth, the light is white. This light holds all the colours of the rainbow in it.
So, if one white light holds all these colours, then how do we see them?
Well, when there's rain, the sun in the sky at the same time of the rain shows a rainbow. This is because the sun shines through the raindrops when it's raining, and the light from the sun gets scattered over the sky into many different colours.
Wow, that's so interesting, Professor Membrane. But there's so many colours in the rainbow. How do you know how many different colours there are in the rainbow?
Well, let's find out. Red, orange, yellow, green and blue, indigo and violet. Did you know them? Can you count them? That's right, there's 7 colours in the rainbow. Red, orange, yellow, green, blue, indigo and violet. 7 colours.
But that's a lot of colours, Professor Membrane. How will I ever remember them all?
I know. Let's have a song to see if it will help you learn. And remember, the different colours of the rainbow, you sing a song too.
Roses are red, pumpkins orange, the sun is yellow, the grass is green, the sky is blue, eggplants are indigo, and violets are violet. Well, that's a flower, you know. Red, orange, yellow, green, blue, indigo, and violet are the colors of the rainbow. Colors are everywhere, you can see it. Colors were made for you and me.
Well, children, Dr. Boron, Genius, did that song help?
Yes, it did, thank you, Professor Membrane. I hope it helped you at home too. But Genius Giraffe told me that he tried to follow the rainbow, but he couldn't find the end after he looked and looked and searched and searched.
Well, Genius Giraffe couldn't find the rainbow because a rainbow is an optical illusion. You see, a rainbow is the shape of... Do you know what shape a rainbow is? It's an arc, just like I showed you in the picture. Let's have a look again. It's like a bridge. That's right. But a rainbow is actually a complete circle. But we only see half of the circle. Do you want to know why?
Yes, please, Professor Membrane.
Because the other half is hiding. You just can't catch it. It's hiding under the ground because the rainbow is an optical illusion. The closer you get to it, the further away it moves.
So we'll never get to find the end of a rainbow.
I'm afraid not, Dr. Boron. But next time it rains and the sun comes out, keep an eye and see if you can spot that rainbow.
Thank you so much for helping us to learn about the rainbow, Professor Membrane. And don't forget to join us next time, where Genius Giraffe will be asking another question about something he's found on his adventures. Until next time, bye!
Bye!
Although it is weather permitting, an experiment based upon the video can be undertaken. All you need is an outdoor environment, hosepipe or watering can and some sunshine.
This will allow the class to create rainbows, something which can be seen as fun, scientific and creative. allowing the pupils to ask as many questions as they want to, many of which were used in the video as an example.
Overall, outdoor learning connects learners with their environment, their community, their society and themselves. Outdoor learning benefits the children to gain knowledge and understanding of the world around them, while undertaking scientific and creative learning in order for them to provide a better future for themselves and others. We hope that after watching the video created, you will agree that teaching science can be about a creative endeavour within the statutory science requirements and limitations.
We continually hope that schools can arrange time and effort to embed scientific and creative learning within education, as well as allowing subjects to become fun and knowledgeable while learning in an outdoor environment. As stated earlier in the video, WAG 2008 believes that the child's curiosity and disposition to learn is ought to be enthused and inspired through everyday experiences, both indoors and out. Therefore, embedding this knowledge into children from a young age can develop a natural understanding of the world around them. Therefore, an outdoor classroom environment can be seen to help develop a child's scientific and innovation skills.